Okay, this is 2.433. Find the sequence of elementary matrices whose product is given non-singular matrix. So what they want in here in this question is, suppose when you do E1, E2, say uh, by operating elementary matrices, and suppose you get identity. Then when you multiply both sides, E3 inverse, E2 inverse, and then the last one is E1 inverse, E1 inverse. When you multiply to both sides here, E1 inverse, E2 inverse, E3 inverse, then see here, they can all cancel out. Is that right? They cancel out. Okay. So what's left? A is E1 inverse, E2 inverse, E3 inverse. That's what that means. These are non-singular product of non-singular matrices. A is equal to. Okay. So now let's start here. So now first I'm going to add R1 plus R2 goes to R2. So here, this is E1, okay? This is E1. Now, so it is 1, negative 2, 0, 0, 1, 0, 0, 0, 1. Okay. So now, so next one is, we like to make this guy 0. So twice of R2 plus R1 goes to R1. So that means 1, 0, 0, 0, 1, 0, and 0, 0, 1. So we have, I3 here. Now this is E2. Okay. So first elementary operation is R1 plus R2 is R2. Now, then what is if E1 is R1 plus R2 goes to R2, then what is E minus 1? Inverse. That is negative R1 plus R2, R2. That is what. This is, you add one copy of R1 to R2. The inverse is, you add R1. So now inverse is subtract R1. Okay. So what is this? The third row is nothing involved. 0, 0, 1. So 1, 0, 0. Negative R1 plus R2 is R2. So negative 1, 1, 0. That is what E1 inverse. E1 inverse. Now let's look at E2. What is E2? E2 is 2 copies of R2 plus R1 goes to R1. So inverse of that is just like, you add 2R2, so negative 2R2 plus R1 goes to R1. Okay, so inverse of that is, so what is it? It is 0, 0, 1, nothing change R3, and then 0, 1, 0, and negative 2 copies of R2 and R1, so this is going to be negative 2 and 0. So this is inverse of E1, this is inverse of E2. Okay, so here, what is A? So we only have a 2 elementary operation involved. A is E1 inverse times E2 inverse. Okay, so what is the E1 inverse? 1, 0, 0, negative 1, 1, 0, 0, 0, 1, and then 1, negative 2, 0, 0, 1, 0, 0, 0, 1. Okay. So that's what I mean by find the sequence element matrix whose product is given A. So let's confirm. So now, you want to multiply these and that. That's going to be 1. And then you want to multiply second copy, multiply with that. So that will give me what? Negative 2. That will just give me negative 2. And the last one is 0. Okay, and then the second row, negative 1, so negative 1, so this is simply negative 1. And then this is 2 plus 1 is 3. And then last column give me 0. And then this is a 0. That is also 0. Last one is 1. Isn't that what A is? Okay, that's what this A is. So that's what I mean by using. So we're using inverse of elementary matrices, product of inverse.